Nest Adventures was a team project that was part of LCV's curriculum. Designed to be a multi-role and combat-focused RPG, Nest Adventures featured a unique character switching mechanic. When performing a dodge roll, your character will swap seamlessly between the ranged and melee characters using animation events and coroutines. Both characters utilize a Cinemachine lock group system to focus the camera on the player and the lock target while avoiding intersection with walls and objects. Unfortunately, due to COVID complications, our team had no artists and only one designer. This was an interesting hurdle to overcome and led to some great experience designing custom editor scripts for Unity. An example of this is the custom editor script for the teleport pad. I encoded a custom button to add a teleport location that would spawn a child entity complete with gizmos. The editor script would automatically hook up the spawned entity as the teleport location without any extra fiddling. This and similar editor scripts streamlined level design and reduced workload for our designer. Overall, this project provided a great introduction to both Unity and team project work. I really enjoy games that not only allow the player to be creative, but reward it. At this point, I had just finished work on Nest Adventures and was much more comfortable with Unity. This led me to start the Gunbuilder project. I wanted to build a weapon system that was unique and fun to experiment with, while also being easy to handle. Weapons are built with modules that can be infused with elements and modified directly to alter their behavior and handling. Players can also save their modules for later use. For example, a larger scale barrel will provide bigger projectiles and more damage at the expense of recoil and clip ammo count. Due to the repeating nature of this module-based system, the Gunbuilder project uses generic code wherever possible. Along with interfacing techniques from C#, I saved a lot of repetitive development time by sticking to the principles of good object-oriented design. This included the need for a modular codebase so I could build upon the work done here in a project with gameplay. The time spent developing Gunbuilder allowed me to sharpen my Unity and C# technical skills while providing informative experiences in other skills such as planning, scope management, and organization. The Gunbuilder concept needs more features and polishing before it's ready for a real project, but I'm happy with the progress I've made so far. Clink Engine is the name of the custom game engine I built using C++ and DirectX 11. Initially started as a learning platform at LCV, Clink Engine has grown beyond the scope of the classroom and has recently helped me experiment with different projects and learning experiences. I've used Clink to learn more about artificial intelligence, including pathfinding algorithms, finite state machines, agent steering behaviors, and agent perception and memory. I have a special interest in algorithms like flocking that are simple to use but provide complex behavior. Clink Engine also provides a growing linear algebra library that handles a multitude of things like graphical vertices, spatial transformations, and uniform random functions. As for rendering, a custom tool was built using the Asset Importer API for converting FBX files to Clink readable data. Clink also features an internal shader manager to help create custom shaders for learning new rendering techniques. More recently, I've used Clink to implement machine learning algorithms. Though not used for an actual project, the experience has lifted the veil on the mysterious world of machine learning. One of my game development interests is procedural generation. I decided to use my own engine to build realistic-looking terrain with noise-based height maps. One issue when using pure noise is that drastic height changes look very unrealistic. So during my research, I came across the idea of simulating raindrops on a landscape. The droplets erode and deposit sediment to modify the height map's values, producing an organic-looking terrain. This experience has taught me a lot about shaders, procedural geometry, and that complex-looking math in white papers isn't always that scary.